you need to understand what we have learned so far in order to understand how Arbitrum works. So today we'll be looking at understanding Arbitrum as a technology and also as a blockchain. So we need to understand that Arbitrum is both a technology and a blockchain. And then we'll look at the roles and functionality of validators and sequencers in blockchain networks. All right, so I'll just give 1 minute for those of us to join in before we start, so we don't need to keep coming back. So by 10:10, we'll just kick off. All right, so we're going to start with understanding Arbitrum. Now, Arbitrum can be considered both a blockchain and also as a technology. Now, I believe most of us understand what the technology means, what technology, the terminology technology means. And then by now, we should also understand what blockchain means as itself. So we need to understand that Arbitrum can be considered as both a technology and also a blockchain. Now, that's the first key aspect you need to understand about Arbitrum. Now, we'll be looking at Arbitrum as a blockchain. Now, Arbitrum is a layer 2 solution that scales Ethereum. Yesterday, we understood layer 2 solutions and what they do. And then we also said Arbitrum, we gave the description of the example. The Arbitrum is a layer 2 solution. That was in yesterday's slide, so you can just check that out. Now, Arbitrum is a layer 2 solution that scales Ethereum. There are two chains. We have the Arbitrum 1, a roll-up chain, and Nova, an AnyTrust chain. Both support smart contracts, but Nova has lower transaction fees, while Arbitrum 1 is more secure. Now, to understand this, Arbitrum 1, which is a roll-up chain, what did we say is a roll-up chain yesterday? We said roll-up chains are thank you. So it bundles transactions into a single batch and then settles it back to the L1, that is the layer 1. Now, that's Arbitrum 1, which is a roll-up chain. That is, makes use of this optimistic roll-up chain, which is the one where it just assumes the validity of the transactions and proposes it to submission. And then we also have Nova, an AnyTrust chain. Now, I'm sure we are wondering what AnyTrust means. As we proceed, we're going to understand AnyTrust chains. Is among these slides. So we're going to have a better understanding of what AnyTrust chain does. Now, we need to also understand that both of them, both of the chains, they actually support smart contracts. That is, smart contracts can be deployed to any of the chains and can be compiled to any of the chains. Now, from next week, from Monday, I believe we'll be taking a look into Solidity. So once we begin to enter Solidity, we'll actually have a better understanding of smart contracts. So we just need to understand that both of them support contracts. But a key difference between both of them is what? Nova has lower transaction fees. So because of what was implemented in AnyTrust chain, it actually has lower transaction fees. And as a result of this, actually the Nova was actually created in order to reduce transaction fees And then the use cases involves gaming, where they require lower transaction fees, or even where micropayments are involved. So we'll still take a look at that later on. Why Arbitrum 1 is more secure. Why is it more secure? Because Arbitrum 1 makes use of the full Arbitrum Nitro. I'm sure it all sounds confusing right now, but we're going to get a better understanding of it. So I'll just move on and then we'll explain this better as we proceed. Now, Arbitrum as a technology. Arbitrum is a technology suite designed to scale Ethereum. It uses an optimistic rollup, which by now we should know. And then there are three main tech stacks in the Arbitrum technology. We have the Arbitrum Classic, we have Arbitrum Nitro, and Arbitrum AnyTrust. Arbitrum Classic, Arbitrum Nitro, and Arbitrum AnyTrust. So we'll look at the brief explanation for Arbitrum Classic, Arbitrum Nitro, and Arbitrum AnyTrust. Okay, good. What is Arbitrum Classic? The Classic is the original tech stack used by Arbitrum, that is the initial one that was launched and used by Arbitrum. It is no longer in use, that's why it is depreciated. Yeah, and it utilized a custom-made virtual machine, the Arbitrum virtual machine for compilation. To understand what virtual machines are, they're like environments where the environments that can run certain softwares or applications, right? So virtual machines are actually quite popular right now in the internet space, even in the computer science space. Virtual machines are quite popular. And yeah, so it had its own custom-made virtual machine, which was the Arbitrum virtual machine, which was used for compilation. Now, we're not going to pay big attention to it because um, Nitro and AnyTrust are the technology being used right now by Arbitrum. Now, Nitro represents a significant upgrade to Arbitrum Classic. Now, the Nitro was built on is actually an upgrade to the Arbitrum Classic, and then it comes with several improvements. Some of the improvements include advanced core data compression, which reduces the data posted to L1 and drives down transaction cost on Arbitrum. Now, in understanding roll-up chains, we understand that the transactions are done off-chain and then they are settled back to the layer one, right? And meaning data is going to be posted back to layer one. What Arbitrum Nitro does is that it reduces this data that gets posted back to L1. And as a result of that reduction in the data posted to L1, the transaction costs are actually reduced. So this is how Arbitrum Nitro drives down the transaction costs on Arbitrum. So with this, you actually get lower transaction fees compared to the normal transaction fee you would pay on L1. Now, Arbitrum AnyTrust is a technology that is a variant of the Nitro. So what it does is that it operates by relying on an external data availability committee to store data and provide it on demand. Now, this committee consists of n members. That is, it could be a committee of any amount of members. It could be 20, it could be 10, it could be 100. So n is, those of us that are math students, we should understand what n means. N numbers can be any number. Members can be any number. And AnyTrust assumes that at least two of them are honest. So what AnyTrust does is it makes a mild assumption that, okay, in this committee, there are 20 members, and out of these 20 members, two are honest. So that's the assumption AnyTrust does, and that's like the technology involved in AnyTrust. So just like the name AnyTrust, it makes that at least two of them are going to be honest. Now, this assumption allows AnyTrust to reduce cost while maintaining the necessary level of trust. this is a balance between efficiency and decentralization. So it maintains this trust by, okay, if two are going to be honest, it means the data is going to be, okay, let's take it from this point. The data is going to be held and stored by the data availability committee. Remember, it's a committee. So the data is going to be with them. And it's going to be this community, whenever the data is required, the committee is going to provide it on demand. So we'll be like, oh, hey, I need so documents, or I need so transaction data. It's that at least two of them are going to be honest. I'm going to provide the data required. And as a result, it actually gives a balance between efficiency and decentralization. Now, with this, the amount of, instead of sending the whole full data back to the L1, it actually sends a certificate. There's this DAC cert that is sent to the L1. Do you have any question? Or are we still confused on how AnyTrust works? Please, if you want me to go through it again, I can go through it. So just signify. Do we all have a basic understanding of AnyTrust and Nitro? Oui. Okay, since nobody is saying anything, I will just move on. All right. The use case of AnyTrust includes gaming platforms and microtransactions. I said this earlier on. Now, how does Arbitrum rollup functions? How? So we're going to be looking at how does Arbitrum rollup functions as a scaling solution. How do we scale Ethereum using Arbitrum rollup? First point is off-chain computation. We understand that transactions are done on the off-chain, and then they are bundled and sent as a single batch back to the layer one. So that's the scaling solution that Arbitrum rollup uses to scale. Yeah. And then the second one is multiple round fraud proofs. So what I'm talking about fraud proofs is when we talked about optimistic rollups, where in case of a fraudulent activity, users can flag it up and then it can be investigated to prove the validity of the transaction. So that is another solution. Multiple round fraud proofs. And then we have batching transactions. So since it's costly to pay for transaction fees per transaction, so the fact that the transactions are being batched, it actually reduces the transaction fees involved. And then we have generating validity proofs. The validation of each transactions can be proved. And we have the trustless nature and visibility. Trustless nature as in optimistic rollups, where it has the mild assumption that the transaction is valid. And then we have visibility. It can be seen what everything happening can be seen. Now, benefits of Arbitrum rollup, we have reduced fees, scalability, and then the Ethereum virtual machine compatibility. That is, Arbitrum offers, I believe by now we understand how Arbitrum reduces transaction fees. And we also understand how it makes, how it stands as a scalable solution. Now, in terms of the EVM compatibility, is that it can be used with Ethereum. That is a virtual machine. The EVM is like a virtual machine where Ethereum can connect to probably other solutions. So it's the fact that it's compatible with Ethereum and can be used in order to build your solutions or your decentralized applications. So any questions so far about the benefits? Or even how it functions as a scaling solution? Any question? Well, let me just check the chat. Right. No questions so far. Okay, moving on. We'll be looking at the Arbitrum orbit chain. It is an ideal way to launch your custom chain. So for those of us that want to experiment and launch your individual custom chain, Arbitrum Orbit is a solution that helps you to do that. So it uses the Arbitrum Nitro tech stack to offer low transaction fees, and then it also provides security for your chain. So you don't need to go through the stress of what security should you use for your chain. It already provides the security, and then it also offers low transaction fees for you for your chain. Now, the customization here includes gas token, privacy, permissions. So whatever your project needs at that particular point, this Arbitrum Orbit can be customized to meet your need. So the link is going, I'm going to just drop the link to us on Notion, or you can just quickly view, I think you can just Google it out. Yeah. Now, this is the Orbit documentation. And then you can see it is a universe of chains. It allows you to launch your own custom chain. And then you can decide to learn more, or you can decide to launch your chain. So we have like, there's like the full documentation here. But in a nutshell, you just need to understand that it is used to create. Okay. Okay, let me just, I'll drop it via WhatsApp. Right. So sent. Now it has in documentation, I'm sure you can see some benefits, some possibilities involved. The fact that you can control the permission access, you can control who reads your chain data, you can also control who deploys smart contracts to your chain. Now you also can collect fees based on the token that you chose, and there are numerous benefits and possibilities using this Arbitrum Orbit. So you can just play around with it whenever you are free. And if you have any question, you can always throw it out for them to for the answer to be there. All right, moving on. Okay, so I just want somebody to. I think we have taken Arbitrum as a technology, and I just want somebody in the next 2 to 3 minutes to should us pick up on how we understand how Arbitrum helps to scale Ethereum. So to just give like a brief understanding of Arbitrum as a technology. We understand what technology means, and how do you feel Arbitrum is a technology? What does it offer? So anyone online or physically can just speak briefly for the next 2 to 3 minutes. Please, you can signify for those of us online if you want to just speak. So I just want you, in your own understanding, to explain Arbitrum as a technology. I actually know that we understand Arbitrum as a technology. Anyone? Nobody's raising up their hands. Who wants to try? All right. So we have someone physical. Please introduce yourself and then we can go ahead.
Okay, my name is Kazim Lukman. Okay, Arbitrum is a layer 2 technology in blockchain, and the way Arbitrum helps to scale up Ethereum is by using Rollup, which is 1, and the ZK, which is 2. The Rollup is a technology that Arbitrum used to bundle batch of transactions into a single transactions off chain. Then after it's processed, it's later send it to the main chain. So the second thing is the rollup, the optimistic.
Okay.
So it also uses the technology to assume that the transaction is proven. Like there is no, except if someone have a issue with the transaction and the person can raise a proof.
Oh, okay.
That's
understanding. All right. Thank you very much for that. Kolawole is raising up his hand, so you can just unmute and speak, Kolawole. Are you there, Kolawole? Okay, Trust, you can go ahead since Kolawole isn't here. So, Kolawole, what do you mean by mic is muted? You can't unmute yourself? Okay, let me see. Well, please just give us a minute for the. Okay. So just give us a minute. Let's unmute everybody.
Once this guy is around, Precious, do you know her?
Okay, I think I can talk now. All right, without further ado, and in addition to what Kazim Lukman has said, the Arbitrum is a layer 2 solution that just improves Ethereum. It boosts speed and it improves scalability, adding additional privacy
There's
features.
this project we were working on last year.
And also it
Please,
enhances
moderator,
network
please, can you
throughput
mute?
that facilitates transactions at a cheaper rate. I think that's all I will be adding to it. Thank you. Hello, did you get me? Hello?
Sorry, please, can you just come again? There was like an interference, so we couldn't really hear you. Please, just come again.
All right, I said that in addition to what Kazim Lukman has said, the Arbitrum is a layer 2 solution which improves the Ethereum system. It boosts speed and enhances scalability. And also, it improves the network throughput to facilitate fast transaction at a lower cost. I think that's all I will be adding to it. Thank you.
All right, thank you very much, Kola Wale. So she said it helps to improve throughput. You understand throughput is what? Transaction per a given time frame, could be per seconds per minute. And while it does that, it also reduces our transaction fees. All right, good. Please, our moderator, do you have any contribution for us about Arbitrum as a technology or any perspective you would want to bring in? All right, seems like our moderator is busy. Okay, so we'll just move on to the next thing. We'll be looking at validators now. What are validators? So I'll just come in and just continue. Now, validators have a crucial role in ensuring the secure progress of a protocol. They can select from three strategies. We have the active validator, we have the defensive validator, and then we also have the watchtower validator. That is to say, validators, they ensure the secure progress of a protocol that is the process involved before, let's say, a transaction can be confirmed or even settled, that is added back to the layer one. So validators have a crucial role. Now, validators are most times it could be members like nodes, it could be nodes, it could be you, it could be me, you can act as a validator, but not necessarily all users. All users are not validators. Now, talking about the active validator strategy. Now, it tries to advance the state of the chain by proposing new rollup blocks. An active validator is always staked because creating an out block requires being staked. What do you mean by being staked? It means you have a certain amount blocked up in the chain. So that's what we mean by being staked. So an active validator is always staked. That is, he has kept some money inside the chain, and the chain knows that okay, this belongs to this particular validator. Now, a chain only needs one Onyx active validator. Any more is an inefficient use of resources. For the Arbitrum one chain, off-chain labs run an active validator. So you need to understand that in Arbitrum one, an active validator is used. So what they do is that so I'm just going to explain the defensive, and probably with the defensive, you actually understand what active does and what defensive does. So to give you a better overview. Now, the defensive validator strategy monitors the rollup protocol and refrains from staking if everything is correct. Now, in active, the validator would always have a stake inside of the chain. But in terms of defensive, when just like the word defensive, it means you are not you don't take an action until something offensive is coming at you. So that's like the word defensive. Now, in this context, defensive, it means you are going to reframe, you're not going to stake while everything is correct. You don't need to start fighting when nobody's fighting you. It's actually when somebody comes at you that you begin to defend yourself. So this is it. Once everything is correct, you don't stake. There's no need to stake. How does it work? Is that whenever an incorrect outblock is proposed, the strategy takes action by posting a correct outblock or staking on a correct outblock that another party has posted. This approach aims to avoid staking when things are going on well. But if someone is dishonest, the strategy takes stakes to defend the correct outcome. So in a case where so like in a case where probably a transaction is invalid or something, so once it's been flagged or noticed, now these validators, most of them are private. You might not really know them. Right, there are some that are actually public, but it could be depending on a particular validator at a particular time. So now they're actually monitoring every proposed block, our block in specific. They're monitoring it. And once they notice one that is incorrect, they try to now defend, they try to defend, they try to just fix it by defending the correct outcome. So that was like the difference between the defensive and the active. Now, lastly, we have the watchtower validator. What they do practically is that they don't stake, they don't put any money inside, or they don't lock up any money. They just monitor. So they monitor the rollup protocol, and then they alert others if it detects an incorrect outbound proposal. Other parties who have staked are assumed to be willing to intervene in order to claim some of the dishonest proposal stake before the deadline for the dishonest outbound proposal expires. Now, whenever a dishonest, so everybody proposing must have a stake, right? And in a case where you are dishonest, there's a high chance where your stake is going to be slashed or even claimed by someone else. So you won't be able to access your stake. And as a result of that, you see most people are actually honest because nobody wants to lose that money involved in the chain. So in a scenario where dishonest proposal stakes, yeah, the ones that are staked can actually come in to intervene. So what these watchtower validators do is that they just monitor, and once they see an incorrect roll-up block proposal, they actually flag it up. People that have stake can now intervene. And then there's always a deadline for a dishonest roll-up block proposal. Now, any question on these strategies? Okay. Now, so just to know, these validators, they actually have like they actually have different methods on how they validate how they validate. So depending on the particular chain, actually some of them set up as much, they have security mechanisms involved that can actually pick up incorrect outblock proposals. And then some actually check for security vulnerabilities in smart contracts deployed. So there are different approach validators use in order to validate the roll-up block proposal. And lastly, we'll be looking at sequencer. So it is a key component of the Arbitrum blockchain. Its responsibility is that it submits transactions onto the L1 chain. Now, where we said most of the roll-up chains, once the transactions are bashed into a single, once they are bashed, right, they are submitted back into the L1 chain. So what's responsible for submitting the transactions onto the L1 chain are the sequencers. So while it can take different forms, the current sequencer that is in Arbitrum is a centralized entity. However, regardless of its form, the sequencer must operate under its security assumptions and cannot derive security directly from layer one. What this means is that each sequencer has its own security mechanisms involved before it can submit the transactions to the L1 chain. So in their different forms, they must have their own security assumptions, security mechanisms that must, like, the security must be tight, and most times it doesn't derive the security from layer one. No, some layer two solutions, they actually rely on the security of layer one, since it's like the layer one is like foundation. But in sequencers now, they don't derive that security directly from layer one because they have their own security assumptions. So this security, they secure yeah, so that's just what sequencer does. So any question? Any more question? Any more question or contribution? Okay, so can you give him the mic? So,
Good morning, everyone. This is Samuel. So I wanted to ask why the sequencers cannot derive security from layer one directly. Why is that not possible?
okay, so that's because I think I already mentioned that it has its own security assumptions, and then it must operate under the security assumptions. So nothing like relying on the security from the layer one. It must operate within its own security assumptions. So yeah, so I think that's why you can't rely on layer one security.
Okay. But
Yeah.
also, when we talk about blockchain, uh,
So it's
we
like our moderator
when we
wants to
talk about
contribute to that.
blockchain, can you hear me?
Okay, yeah, okay, we can hear.
We
Okay, please, can we just?
emphasize.
I think our moderator wants to speak briefly on that, so let's just give him a bit of time.
Okay, so another thing about the sequencer is the sequencer is a centralized entity. And as of today, the only sequencer we have is managed by the off-chain labs. It's managed by the off-chain labs. So it's a centralized entity, and that's why we said there are some security assumption when it comes to sequencers. I hope I'm clear with that. Okay, thank you.
So we physically we didn't hear you. I think network broke.
Okay, what I said the Arbitrum sequencer is a centralized entity, and it's managed by the off-chain labs. So that's it. So that's why we have some security
Yes.
assumptions.
Do we get it? All right.
Yes.
We cannot see your
Yeah,
network.
that's the second question. He answered it also that maybe because it's a centralized, because I also saw somewhere
Yeah,
that
it's
it
a
is
centralized
centralized.
entity.
Yeah. Thank you, sir.
All
Yes, but one thing is that if you go through the Arbitrum documentation, you would see that the off-chain lab, they promise to make sure that they run the sequencer in a trustworthy way. So that's why we can always assume they will do well. So that's it.
Okay, thank you very much, our contributor. Please, any other question? Okay, in the absence of none, we're going to just proceed to take up our assignment for today. Yes, let me access motion together. Please, our moderator, can we get the assignment? I'm having issues accessing Notion. Okay, thank you very much. So our assignment for today is what? Conduct a research on Arbitrum sequencers, their importance and limitations. So we'll be focusing on Arbitrum sequencers, and we'll talk about their importance and also their limitations. Do we have any question on that? I believe it's supposed to be individual, but I'll leave that to our moderator to speak on it. Yeah. Because our moderator, is it an individual work or group work?
It's an individual work, so you are meant to submit individually. You can post the assignment on Medium or Hashnode. Then submit the link to the Notion board. Yeah, the deadline for the project
So
is
is it going to be in form of an article?
Yes, it's going to be in the form of an article. And as I've mentioned before that, all the assignments for this week can combine everything in a single article. So you don't need to worry about submitting multiple. You can just combine everything in a single article if there's a way for you to do that. Then the deadline is 11:59 p.m. tomorrow, which is Friday.
Okay. Yes, 11:59 p.m. You can connect the mic and ask.
All right. Please, I also want to ask for the next class, which is going to be next week. You mentioned that we'll be studying solidity. Are there things that we need to prepare with? Maybe some things we should get ready. Maybe it's going to be a practical section, maybe our laptops or things like that.
Yeah, so I was supposed to speak on that before the class ends. So I think I'll just go ahead to speak on that. Our next class is going to be on Monday, and we'll be diving into solidity. And at this point, we should understand that solidity is a programming language. And that means we'll be having practical sections. And these practical sections, it will require some setup, I believe. Right now, we already have MetaMask, so we don't need to worry about MetaMask. But there are online editors we can use, which is Remix. So I'm just going to provide I'll send the necessary links on WhatsApp, such as Remix, and you can just play around it. Even for some of us, we can even go ahead to probably learn one or two about solidity before Monday, so that everything doesn't look like like it doesn't look new in our eyes. So I would want us to do that, to just probably skim through solidity and understand what solidity is, what's its use, why was it created, understand the foundation to solidity, so we'll know, okay, this is what solidity does and all. All right, so yeah, I would send the Remix link to WhatsApp. It's going to be our online editor. I'll be making use of that for our practical session. Please, let's endeavor and ensure that we connect with our laptops before the class, so we can just dive right into the practical session. All right. Any other setup? I think we can do that on Monday morning. All right. Thank you very much.
So thank you very much, everyone, for coming. So we're ending the class now.
All right. Goodbye, everyone, and have a nice weekend. See you on Monday.